This video explain example for serviceability and shear. So series of the steel beams, which is a series of steel beams. There are 3 steel beams, span 6 meters. So if I draw the 3D, the span of that beam is 6 meters along this way, simply supported. So the ends are simply supported, and reinforced concrete floor step in a public hall that will be used as a dance floor. So these steel beams are carrying this reinforced concrete, which is 150 millimeter thick, and this slab is used for dance area. Connectors are provided between the beams, and the slab will not be capable of ensuring composite beam action, but will ensure that the beam is continuously restrained. So the connection between here and here, how using the studs or any other connection that we use to connect the steel beams, and they are not. So we need to find the shear capacity of this. We need to design this steel beam for shear and for serviceability. Now the distance between the left side of the beam and the beam A is 3.6 meters, and on the right side of the beam and the beam is 4.5 meters. Now there is one more ceilings that are attached to these steel beams, so that ceilings also taken by these 3 steel beams, and it has 0.5 kilopascals pressure that is given in the questions. Now if I draw this one in the 3D environment, like steel beams here and given 6 meters spans, that is 6 meter span given here. So I draw 6 meters, I draw this slab here, and that is 150 millimeter thick, and I draw these ceilings here that I have it in the question. So from 2D I just draw 3D to visualize all the dimensions. Now here we're gonna start with finding the loads, dead loads and live loads cases. So beam A supports a width of, so first of all we need to find it out how much width the slab will be taken. So as you aware that these beams would have a carry this 3.6 divided by 2, which give us 1.8 meters, and if I have a half of here, it also carry 4.5 divided by 2, that give us 2.25. so 1.8 plus 2.25 give us 4.05 meters. So these steel beams have carrying this width of this one, which is half of on the left side and half on the right side. So other half would be carrying by this beam and this beam. So we have 4.05. That's how I calculated 4.05, which is the width of this slab that would be carried by these steel beams. Now dead load carried by the beams. Now understand the story here. This steel A is going to carry the weight of the slab. It's going to carry the weight of the own weight and also weight of the ceiling. So there are 3 dead weight coming to the beam A. So we're going to do it one by one. First we're going to find the weight of the slab, then we're going to find the weight of the beam A, self weight of the beam A, and then we're going to find the weight of the ceilings, and we can add them together, and all these weights will be calculated in kilonewton per meters. So first let's talk about slab. Now we need to always, the loads coming onto the slab is a UDL. So this slab would have created the UDL load due to the weight on the steel beams in that fashions, right? So that is the UDL load that is coming onto the beam A. Now density of the slab is given in the questions, that is written here. Density of the slab 25 kilonewton per meter cube. So we have a density 25 kilonewton per meter cube. We need to find UDL, so density times the perpendicular area. So as you can see, UDL load is coming on here, so the perpendicular area that we are considering to that UDL load is this one. Please note, we are not taking this area because that is parallel to this UDL load. So if you are taking this UDL load, in that case we might take this area, but we need to take this area, which is 4.05 times 0.15. that's what written here. Perpendicular area 4.05 times 15, which is this perpendicular area, that give us 15.19 kilonewton per meter. Now this numbers is telling me that this slab is putting this 15.19 kilonewton per meter UDL load onto the steel beams. Now next one, we going to talk about the ceilings, that we have how much load is carrying by the ceiling in kilonewton per meters. Now pressure is given for the ceilings, which is 0.5, that is given in the questions. Ceiling has a pressure of 0.5 kilopascals. Now that pressures times the perpendicular distance, as you can see here, I can use this one. These ceilings also have a UDL load carrying by this applying to these steel beams. So if I want to calculate the UDL load, pressure times perpendicular distance, so the perpendicular distance is 4.05, which is in here. So that give us 2.02 kilonewton per meter, and that 2.02 kilonewton per meter is the UDL load applied by ceiling to the steel beams due to the weight. Now last one, we are going to calculate how much this beam going to carry the UDL load. Now we have not given which beams that we going to take it, but we going to estimate the beams. So L over D ratio is 20. Let's assume that is the case for these steel beams. L over D is 220. So to find the D is L over 20, and the span of the beam, which is span of the beam, is 6 meters or 6000 millimeters. It's also given in the questions. Span of the beam is given 6 meters. So 6000 millimeters divided by 20 give us 300 millimeters is the depth of the steel beam. So if you find the depth, we can say that we have 310 UB, and we are trying this, we are selecting this 310 because we can see this 300. So we have close to that 300 is 304, that is the depth of the slab, and so we can select 310 UB 40.4 for the depth of 304, just slightly more than what we are found here. So that 310 UB 40.4 we're going to try, and the weight of that UB is 310 UB 40.4, which is 40.4 kg per meters. Now from the one steel tables, it's given here 410 UB 40.4. So we have this 40.4 kg per meter. Now that 40.4 kg per meters, we need to convert into kilonewton per meter. So times by 10 to convert kg into newtons. So that is 404 newton per meters. Then 404 divided by 1000 give us kilonewton per meters. That is 0.404 kilonewton per meter. So now we found 3 different loads. One coming from the slab, that is 15.19. Second one coming from the ceilings, that we calculate 2.02, and the self weight of the steel beams is 0.404. So total dead load carried by this beam A is the weight of the slab in kilonewton per meter, weight of the slab kilonewton per meter, and self weight of the beam kilonewton per meter. So we substitute all these values. 15.19 that we calculated for the slab, 2.02 that we calculated for ceilings, and then self weight of the beam A is 0.4. So addition of this all give you 7.6 kilonewton per meters. Now we need the live load as well. Now this slab is used for the activity that is given, that is dance area. So we need to check in the Australian standard AS and ZS 1170.1. in table 3.1 we need to find a live load that used for the dance hall. Now on AS and ZS 1170 AS and ZS 1170.1 2002 on table 3.1, on AS and ZS 1170.1 on page number 10 table 3.1 in the section C4 we have area with the possible physical activity, and that has a dance hall and studio and gymnasium. It has a 5 kilopascals is a live load that is we obtain from this Australian standard. So that is the live load 5 kilopascals taken from Australian standard on page number 10 on table 3.1. Now we have given that pressure live load, so we can convert this pressure into the UDL load 5 kilopascals times 4.05. And for example here if I have these pressures which is coming due to the dance, and that is 5 kilopascals, and I like to convert these pressures into UDL load. For example this UDL load, So this pressure, if I want to convert this UDLR, so pressure times perpendicular length, which is 4.05. So that pressures 5 times 4.05, which is 20.3 kilonewton per meters. Now we have a dead load and live load. Now we need to combine the dead load and live load. So we have a critical load combinations given in the Australian standard AS 1170.0 on page number 15. On page number 15, AS and ZS 1170.0 for strength, we have 1.2 times dead load plus 1.5 live load. So that's the equation here that I obtained from this Australian standard. So 1.2 times the dead load 17.6, dead load we calculated 17.6, that I substitute here, plus 1.5 times 20.2, that's live load, is equal to 51.6 kilonewton per meters. That is the W, uniformly distributed load. That is the total load carried by this beam A. So this is beam A. So I draw this beam. So that is beam A. Draw it in the line diagram, and that is 6 meter span. So we do the structure analysis first. We can draw the shear force diagram, and the shear force diagram W divided by 2. So 51.6 times 6 divided by 2, that is given 154 kilonewton, the maximum shear force. And the bending moment here, that can be obtained by WL over 8, which is 51.6 times 6, that is W, times the length is 6 meters, divided by 8, given 213 kilonewton per meters. We continue the examples for shear and calculating the shear capacity and the deflection capacity in the next video. Thank you.